Hi everyone. For this question, it says in any of its shipments, a company found that the probability of bad orange it supplies is 0.2. So we have a situation probability about bad orange 0.2. At the receiving terminal, a sample is taken at random and the number of bad oranges is recorded. A shipment will be rejected if there are more than 10% of bad orange in the sample taken. Calculate the probability the shipment will be accepted if the sample given here is 20. So n is 20. So we are calculate on the number of bad oranges. So x distributed binomial sample 20 of them is about bad 0.2. So now we want to calculate the probability of the shipment will be accepted. So it will be rejected if we have 10% of the bad orange. So 10% of the bad orange, it means that 1 out of 100 times 20 of the sample. So here will give us 2. So means that if your bad oranges more than 2, we will going to reject this shipment. So but now they want to calculate the probability for this shipment to be accepted. So for the shipment to be accepted, the bad oranges have to be less than equal to. Alright, so you'll be if your number of the bad oranges more than 10%, so number of bad oranges more than 2, it will reject. To accept, you have to less than or equal to. So based on this distribution, we can use binomial table where sample is 20, p is 0.2. So it will be in this table. So to get less than equal to, we need to read from the table using more than equal sign. So 1 minus probability x more than equal 3. Since we need the equal to here, 2 is needed from the question, we will minus the number that not needed in the question. Start from 3. So the reading for 3, it will be 7939. Then we go for question B. Use the normal approximation, estimate the probability obtaining 182. So means that start from 180 to 210 for these bad oranges if sample is equal to 1000 orange are inspected at random. So now x is distributed binomial, sample changed to 1000, still considered in the case of bad oranges, which is 0.2. So from here we can notice here the first condition where n equals to 1000, which is large. Second condition, we calculate NP 1000 times 0.2. So it gives us 200, which is already more than 5. So already fulfill the condition. Number 3, the probability is in between 0.1 and 0.9. Yes, probability is equal to 0.2, which means that this distribution need to change to normal with mean 200 that we already calculate. Then now we want to calculate what is our variance. Variance is NPQ. So 200 times Q 160. So starting from the question saying that 180 until 210 up to, so got equal. So in this situation, originally our distribution is start from binomial. So because of the condition that can fulfill, we use normal distribution to approximate this binomial distribution. Then we solve in normal way, which is change to z-score, draw the standard normal graph, then find it from table to get answer. So we want to change to normal from binomial status x here, change to normal distribution, we need to do continuity correction CC, whether we have to plus 0.5 or minus 0.5. So as you can see, 180 until 210, this is included. This is the region that we want. So we want to do CC, add in 0.5 or minus 0.5. So it's supposed to start before 180, after 210. So the boundary will be start like 179.5 until 210.5. So you cannot, for 210 you have to add 0.5, but for 180 you have to minus 0.5. So after we make it to normal distribution, after we make it continuity correction, so the next step is changing this x to standard form to z-score 179.5 need to minus mean 200 over standard deviation square root of 160. X change to z. Make sure our z-score only in 2 decimal. So the z-score in 2 decimal, it will be negative 1.62 and 0.83. Then we draw out this standard normal graph. Negative at left hand side, positive at right hand side, in between. So to get the area in between this distribution, our table only present our tail side value. So to get this in the middle region, we were taking overall minus the tail. So the negative tail, we will read it as positive 1.62. And then minus another right tail here, which is 0.83. So read it from the standard normal table. One point six two, 1.62, 0.526, 0.83, 2033. Simplify this. So here we have our answer.